Welcome back, my super scientists. I welcome you to the new section 2025 through 2026. I hope your holiday was great and I hope you did have a lot of fun. So the first topic we'll be treating this section is the model of atom. Now get ready to step into the mystery world of atoms, the tiny building block that makes up you, me, the air we breathe, the food we eat, and everything around us. Now, in this exciting section, we will uncover what an atom really is, the story of how atom was discovered, the three invisible particles that live inside the atom, and how electron dances in their shell like planets around the sun. So, buckle up, open up your conscious mind, and let's begin our amazing journey into the model of atom. Come along with me, let's learn. So, the learning objective of this lesson include the following. At the end of the lesson, you should be able to define and explain the model of an atom. Recall and explain the contribution of key scientists in the development of the atomic model. You should be able to identify the three subatomic particles, their charges, their location, their mass in the atom. Then you should be able to create an atomic model and correctly label its parts. So at the end of this lesson, these are what you must achieve. So let's dive right in. Imagine everything around you: a chair, a book, even the air we breathe. What are these things made of? They are made up of tiny particles called atoms. Now, I want you to think of atoms as a building block of all matter, just like the Lego bricks that can be combined in different ways to build different structures. Just like the bricks you use in building houses, you could combine it in different ways to build different kind of structures. Now, atoms combine in various ways to create everything that we could see, that we could feel, and that we could touch. So, invariably, everything around us called matter are made up of atoms. So, what do we call atoms? Now, an atom is the smallest form of an element that can exist and still retain the chemical properties of that element. So when you break an element into pieces, the parts that could still retain the properties of that element is called an atom. Now, here are some basic facts that you should know about an atom. Atoms are incredibly small. You cannot see atom with your eyes, even with the aid of a microscope. Now, atoms are always moving. They move randomly. Now, even in solid objects, atoms are constantly moving. There are different types of atoms. There are different kinds of atoms, and this make up a particular element. For example, we have atoms of oxygen element, atoms of hydrogen element, atoms of iron element, and so on. Now, as a matter of fact, the word atom was gotten or coined from a Greek word called atomos. And atomos in Greek means indivisible. So at first, atoms were likened to the indivisible part of an element. However, recent and future and recent discovery made us to understand that atoms are not actually indivisible because atoms consist of subatomic particles. Now, the first person to describe what an atom was Democritus. Democritus was a Greek philosopher. He was the first to describe what an atom is and called it the indivisible part of an element or of a substance. However, various chemists and physicists contributed to the knowledge that we now have about atom. So we are going to dive shortly into the history of atom. So as I said earlier, Democritus was the first to describe what an atom looked like. Democritus was an ancient Greek philosopher and a scholar of Leucippus, who formulated an atomic theory for the universe in 400 BC. Now, he called it atomos, as I mentioned earlier, which means uncuttable or indivisible. Now, he stated that everything is composed of atoms. So he said atoms are indestructible and also have and will always be in motion. He also said that there are infinite numbers and there are different kinds of atoms which differs in shape, sizes, and structure. So, Democritus was the first to describe the structure or to determine the properties of atoms. For example, he explained that water is liquid and it always flows. He also explained that compounds or substances like iron are solid and they are sturdy, that is, they are stationary, they don't move about. So he was the first to describe what the properties of different kind of atoms, liquid, solid, and gas look like. Another scientist that contributed to the knowledge of atom is John Dalton. John Dalton is regarded as one of the greatest chemists when it comes to the structure of atom. Now, in 1803, he described an atom as a hard sphere. He also described that atoms of the same element are identical and different from atoms of other elements. He also described that atoms combine in different simple ratio to form compounds. Now, he brought up all these explanation that we regarded as Dalton's atomic theory. We are going to look at these theories and their modification as we go on in this lesson. So the idea of atom was later redefined by the work of Sir J.J. Thomson in 1904. So Sir J.J. Thomson discovered electrons in 1897. He explained that atoms are made from electrons which are scattered through a sea of positively charged particles. Though he didn't give a name to these positively charged particles, but he did explain that atoms consist of electrons and they are scattered within a well or a sea of positively charged particles. Further work by Ernest Rutherford elaborated more on the idea of atom. So in 1911, Ernest Rutherford discovered that atom is mostly empty space with positive middle. So he reinforced the idea of J.J. Thomson that atoms have a positive middle, that is a positive central. Now, he fired an alpha particle at a gold foil and he discovered that some particles deflected but some passed through. Now, alpha particles are positively charged. So when he channeled this to a gold foil, he discovered that some were deflected and some passed through. So he explained that the deflected particles must have been as a result of positively charged particles in the atom. So he concluded that atoms consist of a positively charged central or middle, which we later called the nucleus. Furthermore, Niels Bohr in 1913 explained that electrons move around the nucleus in orbits of specific energy and sizes. So it was Niels Bohr that explained that electrons are not stationary in the atom, they are moving around in a part called orbit or shell. And he explained that these shell are of different energy levels and of different sizes. He also explained that electrons fit into specific energy levels before they could enter into another higher energy level. The work of James Chadwick finally gave a summary and a vivid explanation of what the model of atom that we now know is. So James Chadwick was an English physicist who received the Nobel Prize for Physics in 1933 for the discovery of the neutron. Remember, electron had been discovered, proton had been discovered. Finally, James Chadwick discovered the neutron. Now, that discovery provided a new tool for inducing atomic disintegration. Now, since neutrons, being electrically neutral or uncharged, could penetrate undeflected into the atomic nucleus, and this led to a new model of atomic nucleus being composed of proton and neutron. So since neutron could penetrate through the nucleus, he concluded that neutron must have been a neutrally charged particles for it not to be deflected from the nucleus. So his work gave a concluding structure to the atom, that atoms consist of electrons, which are negatively charged, protons, which are positively charged and located in the nucleus or the center of an atom, and lastly, the neutron, which are neutrally charged or have no charge, and they are also located inside the nucleus of an atom. Therefore, conclusively, the work of Chadwick gave us the current model of atom, or what we call atomic model. As you could see in the diagram above, that the protons and the neutrons are at the center of the atom, while electrons are located outside the circle, a part that we call shell or orbit. And we could see that these electrons are located at different shell. We have the inner shell and the outer shell of an atom. Now, depending on the number of electrons that an atom has, different shell might be possible. We will look at this different shell under the concept called electronic configuration. So this is the current model of atom, with proton and neutron in the nucleus and electrons on the shell or the orbit. So, why is it important to learn about atom? Now, atom is not just an abstract phenomenon that we cannot relate to our daily living. Now, everything around you is made up of atom. So you see the chairs at home, the air you breathe, the clothes you are putting on, the food you eat, even you yourself, your body, your phone, even the stars are made up of atoms. So it is invariably important for us to learn about atom, since everything around us, including we ourselves, are made up of atom. Another importance of atom is that atoms are the building blocks for all matter. So no matter can exist without an atom. Atom is what comes together to form elements, compounds, mixtures, and everything around us that we call matter. So, what are the three subatomic particles? The three main parts or subatomic particles include the proton, the neutron, and the electron. The proton, as we have discovered before, is positively charged and it is located at the middle or the nucleus. The neutrons are negatively charged, that is, they have a zero charge. They are also located at the center of the nucleus. Then we have the electrons. Electrons are negatively charged and they are located on the orbit or revolving around the atom in the shell. Therefore, the nucleus is considered the core of the atom and it consists of the proton and the neutron. Now, it is dense and positively charged and it makes up most of the mass of the atom. So, the mass of an atom is determined by the magnitude of its positive charge particles, which we call the protons. Electrons are called tiny dancers. Why? Because they are always revolving round the nucleus in a circular part called shell. This shell also represents various energy levels. Electrons are negatively charged, but they are smaller than the proton and the neutron.
So, the nature of atom is very important because it determines the atomic number. The atomic number of an element is the number of protons in the nucleus of that atom. The atomic number is also very important because it determines the identity of an element. For example, the atomic number of hydrogen is 1 because the number of proton is 1. The atomic number of oxygen is 8 because the number of protons in oxygen is 8. So, can you guess where we can find elements? Now, each element is made up of one kind of atom, and all elements are organized in a special table called the periodic table. Examples of elements include carbon, oxygen, gold, iodine, astatine, and so on. The periodic table is just like our multiplication table with rows and columns. But in this case, the position of each element is determined by two things: the atomic number, which is the number of protons, and the number of electrons, which determines the group which an element will belong to. That's all I have for you in this lesson. Remember to like and subscribe to our channel. In the next lesson, we'll be looking at how electrons are arranged in the atom. We'll be looking at the concept of electronic configuration. Till I come your way next time, keep reading, keep learning, and keep aiming for the best in your studies. Bye.